Good evening. Very good evening. Am I audible? Can you see my screen? Good evening. Welcome to this free workshop on natural language processing. Yes, Rohan, good evening. What about others? Can I get some response in the chat box? Good evening. So I am Shankar from Pantech e-learning. I welcome you all to this 1 hour free webinar on natural language processing. Welcome to this workshop. So we are conducting this free workshop after a long time. So we're starting with natural language processing. So I'm happy to be a part of it. Good evening. Good evening. Thanks for the response in chat box. Are you guys interested in natural language processing? What is the idea you have about NLP? Can you guys write about it in few lines in chat box? Good evening. So what is natural language processing? We'll see some introduction about NLP, associated terms regarding NLP, and then what is the practical procedure applied, what are the applications of NLP, and if time permits we'll see the output of a project, how it works in Google Colab. So that will be our agenda for today's 1 hour session. So once again, good evening and I welcome you all on behalf of Pantech e-learning. So let's start. So natural language processing or NLP is a machine learning technology that gives computers the ability to interpret, manipulate and comprehend human language. Okay. So if I want to break this into parts, NLP is a machine learning technology. So it is based on machine learning that gives computers the ability to interpret the human language, manipulate the human language and comprehend the human language. One of the recent, if I want to tell you a common example nowadays, if I want to tell you about NLP is ChatGPT. Most of you guys have used about ChatGPT, right? Yes, natural language processing refers to the branch of computer science and more specifically AI concerned giving computers the ability to understand, right? Yeah, so for example, if I'm building an artificial intelligence, so before going into that, let's see about NLP. So if you want to talk about NLP, you want to understand what is AI and associated branches with that. So talking about these terms, like these are interrelated, right? Artificial intelligence or machine learning or deep learning, NLP, data science. Okay, these are interrelated. So we'll see how it works. So artificial intelligence is the development of a computer or a machine to simulate human-like intelligence and problem solving ability. So imagine you are creating a robot or a rover which is an artificially intelligent creature. So for it to see the world, you will be giving cameras to it. So with the help of camera, it can take a video input. Right. So now you are giving eyes to it. Okay. So for example, recently India ISRO made a huge success, right? In Chandrayaan 3, we landed on moon and we made a soft landing. The lander made a soft landing. And if you have seen the news and read about the articles about it, how Chandrayaan 3 lands on the moon and how AI played a big role in the landing part, because the surface of the moon is not a stable one. Okay, it's not a constant one. It is we will be having lot of craters there. Okay, so the lander, it cannot go like randomly and land on it. So it should find a place where it is proper. So using cameras, it will detect, and also sensors to detect a place where the craters are not there, and if it's a flat surface then it can land. So AI played a huge role here. Okay, like that we have find a crater. So we had that rover, right, coming out of the lander module. So it will be going around the moon. So they found a crater, so that it detected a crater. Okay, with the help of cameras it detected, and so that it has given some signals to our scientists here that it should retrace the path, and they have given a positive signal, so it has retraced and went in a new path to explore, right? So like that, when you give eyes to it, we used to do it with the help of image processing. We will be training the algorithms with lot of images. So the same concepts apply in Tesla cars, right? So nowadays we have Tesla cars which drives automatically. So it detects the lane, it detects any object or any vehicle which is coming, so it should act on its own. It's a kind of artificial intelligence. So now with the help of camera you are giving this, okay? And then when you talk about data science, we are using, once again in data science we will try to find customers, so who are all people interrelated, who are all like we can target, will be doing that, okay, in data science. So in all these things, and when you talk about ChatGPT, so you are typing some text and somehow this computer understands this and it is giving you some reply back which is somewhat correct, right? Most of the time it will be correct, but there are many flaws also in ChatGPT too. So like for example, if you ask simple things, it will be okay, but now if you ask some more complex details, you can see it is struggling, or the results may not be appropriate. So once again we are trying to improve it, right? So in all these things, the main part, okay, whether if it's an image, the image will be converted into numbers and then given to the machine learning model. So when you talk about ChatGPT 2, so we are having text, right? Once again in NLP, we will be doing some text pre-processing, and all the text will be converted into numbers or in numerical format. Okay, so this numerical format, so everything is now in the format of numbers. All the things comes down to numbers, and with the help of numbers it want to decide, right? So if the rover finds a crater, or in ChatGPT you are asking some questions, so that question now turned into a number, went inside the algorithm. Now who are going to decide this? What action should be taken is done with the help of machine learning. So creating algorithms and models capable of making informed choices or decisions by processing data and learning from it. So that's what called as machine learning is. So you'll be creating algorithms or models which has some predefined choices or decisions. So with the help of data it should learn, and whenever you are giving a new data it should take the decision on its own. For example, if I tell you, so if I am training a set of crater images and training a set of normal images, so when you give a new image of a crater, it should match with the previous learned images and tell you that whether it's matching or not. So if it finds, it should tell you that the crater is found or crater is not found, like that. Okay. So moving into the next one, is it clear till now? So what is the role of machine learning? We'll be having data, so that data can be of image or can be of text, or in data science it will be in numbers. Whatever the data may be, you will analyze it and pre-process it and turn it into numbers. So finally it will come down into this format, which is nothing but numbers, and this numbers you will be giving into machine learning algorithm, which will learn and finally give you prediction. Is it clear till now regarding machine learning? Can I get some response in chat box? Can I get some response? So this, okay, fine. Now you have, I hope you understood about AI and NLP, some introduction, machine learning, fine. Then what is deep learning then? So deep learning is a specialized field within machine learning, where instead of this algorithm we will be using artificial neural networks, which are employed to process and analyze this complex data. Okay, so instead of algorithms which we are using here, So this can handle some set of amount, but if you have a huge data which is complex, it's better to go with deep learning, where instead of this machine learning algorithms, we will be proceeding with neural networks. And these neural networks are used to do the same task, but it will provide in a more specialized way. Okay, so here also this data is going to be same. You will be analyzing it and processing it. Finally, you are going to give it to a neural network. So if I want to sum up these three terms, yes, thanks for the response guys in chat box. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. Fine. So in all these things, the deciding factor is going to be machine learning. So now if I talk about NLP, then in the first slide itself we have discussed what is NLP. NLP is a machine learning technology that gives computers to the ability to interpret, manipulate and comprehend human language. So how it is achieved? It's also a part of machine learning. So if I talk about NLP, it's a combination of artificial intelligence, computer science and human language too. So if you want to you need to understand the structure of the language, then only you can build any NLP tool or something like that. Okay. So starting with natural language processing. So when you talk about our human language, we have a lot of languages, and if I talk about the NLP, it's most commonly available in English, and they are trying to add other languages too. There are a lot of new languages are also added. Hopefully after some few years we may get in our local language too. So you guys could try. I'll suggest you that if you learn and try on your own languages, it will be much more good for the community and society, right? And when we talk about English, we have letters, words, sentence, parts of speech and lot of stuffs are there. So these are some of the introductions. I'll explain you about the projects or applications of NLP. And after that, we will be seeing about a library of Python which is called as Natural Language Toolkit. I hope you guys are familiar with Python programming so that we can see some examples. Can I get some response? Is it okay about the introduction part? And are you guys familiar with Python programming? So before going into that, I just want to explain some of the application of NLP. It includes language translation, smart assistant. Smart assistant, can you guys give me some example in chat box? Smart assistant, any of the smart assistant you may know, which answers to your questions, do the task you ask it to do, like mail this person or mail that person, play this music. We have, right? So document analysis, okay, online searches. Nowadays, that common example is Google Chrome. It's a really good example, right? In search engine, you are searching something and you are getting a lot of information regarding that. Okay, so you are getting these details. And predictive text, automatic summarization. Nowadays, okay, yes, Alexa, very good. That's what I am expecting, right? And then automatic summarization. Have you guys heard about it or used it? So yes, Siri. So you can provide some input text, you want to summarize it, you can get it. You can do it from ChatGPT or any other websites nowadays, right? Then social media monitoring, chatbots especially. Chatbots have a lot of applications. Chatbots nowadays, all the companies are moving towards AI, and you nowadays wherever you go, for example, even government is also implementing. Am I correct? I have recently saw in IRCTC, it's few months back they have introduced, I think so. They even have a chatbot which helps you in booking your ticket. If you go and search in the IRCTC website and train ticket booking. Yes, Google Assistant is a common example. Fine. So chatbots. Then sentiment analysis. For example, in social media like Twitter, sentiment analysis are some of the common tools and projects. Email filtering. So I'm having this project with me. So if time permits, we can see some output of this. Email filtering, which is nothing but spam mail or ham mail. It's one of the basic project of NLP. You have some complex advanced applications too. Yeah, these are some of the applications of natural language processing. Is it clear? Any doubts till now, or can we continue with the next step, which is going to be a library of Python natural language toolkit? Yes. It's time for doubt clarifications. If you have, we can discuss or we can continue with NLTK. Yes, we'll continue with NLTK, fine. So, now if you ask me how to achieve this, talking about AI or machine learning or data science, usually we'll proceed with Python programming because the easiness of its use, okay, the shorter code and readability. Then talking about libraries, which is a vast set of libraries available, right? For example, like we have pandas to handle data. Are you guys familiar with machine learning? We have pandas library for handling the data, for basic pre-processing, for numerical things to handle the data. We have NumPy, which is numerical Python library. And then talking about visualization, we have Matplotlib, Seaborn, right? So these are some of the libraries for visualization. So with these you can do some data analysis of your data, and then going with machine learning. So if you want to proceed to a machine learning algorithm, can you directly give your data after analysis? You cannot give it, right? So using these tools you need to analyze your data and then find what are the flaws in your data, what is the important feature in your data. So you'll be proceeding with some of the pre-processing techniques. So can you guys tell me some of the pre-processing techniques? So if you have a data before proceeding into a machine learning algorithm, what all pre-processing you should do? Talking about pre-processing, the data set, the first thing you have to check is null values. Am I correct? Null values is an important factor. So the rest of the things are optional, or the impact will be high with the help of null values. So you don't want any null values to be present in your data set, right? So talking about data sets, usually these data sets are collected from open source. Usually we used to download from Kaggle or any other site, like for example Google Dataset Search. We used to search and download our data sets. But have you ever wondered how these data sets are created? So one thing you can perform is something like web scraping using Beautiful Soup or Selenium. Have you heard about the IMDb website? So they used to commonly scrap this website and take contents of it, like the synopsis of a movie, the title of a movie. So like that you can collect a movie data set for NLP, right? You can do it, right? Have you heard about it? If you haven't, please note down these names. It will be interesting. So if you are interested, you can do it in the later part too. Regarding Beautiful Soup, IMDb website scraping are common examples of collecting data sets through web scraping. And talking about other stuffs, like have you heard about something like a Twitter data set can be collected from Twitter, or a spam or mail data set should be collected from lot of peoples, right? Django is a website for it's a web framework for creating web applications, correct? It's Django. And talking about these things, yes, outlier is also a part. So we'll be dealing with null values. For example, if you are having a heart disease data set, have you wondered how they would have collected? So it's like nearly there will be 1000 rows, and each row will be from one patient. Okay, they won't be enclosing the details of the patient, only their medical features, and then the output, whether they are having heart disease or not, will be there. So some of the persons may avoid such some information, like we will be having some age column, and some people may hesitate to tell their age, so that column will be a null value. So at that time you need to take care of this null value with the help of, you can do it with pandas, you can replace with mean value or median value or most repeating value, or you can drop these null columns if the null value is very less. For example, in my data set, if I am having 1000 rows and I am having only 10 null values, I can drop those 10 rows which is having null columns, right? So what will happen? I'll be left with 990 rows. That is good. But imagine a data set which is having 1000 rows totally, and the null values here is around 500. So if you drop this 500 rows, you will be left with only 500. Whether it's a good practice to drop it? It's not a good process to drop those columns, right? So at that time, whether you want to change the data set, or if you are given with no choice, then it's your decision. You can go with mean value replacement or median value, or else you can do is you can use scikit-learn library, imputer. Have you heard about it? sklearn.preprocessing will be using imputation methods, using algorithms to impute it. And also data has outliers. Yes, correct, outliers we have to deal it, and then we have to encode it, the data, right? Once again, what all the data format may be, but it should be given to the algorithm in numerical format. So we'll be encoding that too. So these comes under pandas and other stuffs. So after doing this pre-processing, what you will do, once it is ready, you will be splitting it into train test split part and giving it into your algorithm. So we have different set of machine learning algorithms, and if you want, you can use neural networks too. So yeah, coming back into NLTK. NLTK is a popular Python library used for natural language processing to work with human language data. So to work with NLTK is a popular Python library. We have other libraries too. It's one of the famous and popular library, and it helps you to convert text into numbers which the model can easily work with. Okay, and NLTK has tools such as tokenization, stemming, tagging, parsing, sentiment analysis, etc. So to start with the library, you have to install it using pip command, pip install NLTK, and you can import NLTK. I am going to use Google Colab. So I have the code, I'll explain one by one. So I'll go with pip install NLTK. So I have some sample text for you to show what is happening behind. We can see it now. So you can use pip install NLTK. So if you don't have it, NLTK will get installed here. Fine. So moving into import NLTK. Now we have imported it, but the thing is, this NLTK is associated with a lot of other stuffs externally. So if you want to use them, every time you run it, it may tell you error that it is not found. You have to download this, that. To avoid such situation, you will be going with nltk.download, and you can pass all to download everything which is required. Okay, so it will be downloading all the collections. Fine. So these are the previous prerequisite steps we will be doing for our NLTK to run or use properly. So once you've done that, I have a sample text I can show you. This is some of the text I have took from internet. Okay, I am storing it in a variable sample. So I'll just print this too. Once this is downloaded, it will be running. It's downloading. We'll wait for it to complete. In the meantime, whenever if you have any doubts or if you want any clarification, please use the chat box to post your messages there. I'll be most happy to answer that. Yeah, it has been downloaded. So I have a sample text, and you can see this is the text I am having. Okay, it's around 4 to 6 lines we are having. Yeah, this is a sample text. I'm just showing this here, and it is inside of this variable sample. Okay, now after preparing this, I wish to tell you about tokenization. Tokenization is a concept in NLTK. It is the process of splitting a text into smaller units called tokens. So these tokens could be individual words, phrases, or even sentences too, depending on the task at hand. For example, by breaking down a text into constituent parts, we can begin to analyze its meaning and structure, right? So, for example, if you perform tokenization, if you have a lengthy sentence, you can turn it into sentences or you can turn it into words, and each of this individual part is called as tokens. Okay, so you can turn it into, sorry guys, you can turn into sentences too. If you have a paragraph, you can turn it into sentences and you can turn it into words also. To transform a paragraph into sentence, you can call NLTK dot sent underscore tokenize, and this will help you to turn into a list. The output will be a list which consists of all these sentences inside of that paragraph. Okay, and coming into word underscore tokenize, if you want to turn your paragraph or sentence into words, you can pass it here. You will be getting a list with a collection of words inside of your paragraph. So I wish to show you a hands-on result about it. So I'm having this variable which is sample, this paragraph, and I'm calling NLTK dot sent underscore tokenize, and let me run this, and I'll print the sentence, and can you see it? I'm getting a list, and this list is separated by comma, and each sentence will be in a different structure of this list. So if I want to print the length of it, I can see the total length of it is 8. Okay, this one. So if you want, I can show you with the index number 2. So we can access a list by index number, right? So in the 0th index, we will be having first sentence. So this is the first sentence, this is second one, this is third one. So once again, in NLTK, our task is to turn these text into numbers, right? Am I correct? Fine. So what we will be doing is we will be doing some pre-processing here. So our task is to reduce the complexity of this text we are having. Okay, so talking about that, so this is a way to convert a paragraph into sentences called tokens, or you can also use word underscore tokenize to convert the same sample paragraph into words in a list. So I'll run this and I'll print the words, and you can see each word is now separated by comma and a list, and even the punctuations are also considered as a word. You want to consider that too. Okay, so now we have converted this into tokens. So if you want, I can show you the total length of it. It's totally this comprised of 156 words, which includes the punctuations also. Including punctuations, we are getting this. Fine. And in NLTK, you can get the parts of speech of a tag. Okay, if you pass the words totally, it will give you the parts of speech. If I want, I'll run this. So you can get whether it's a determinant or a noun or an adjective or a verb, because when you're building a sentence, these things carry information which is important. Okay, in a language you will be having some fillers just to make some sense, right? We will be having some other terms, correct? I can't understand your question. How do you tokenize a character? What is that character? Are you speaking about the punctuations? So you can find the parts of speech of the tag you are having using this. And another thing is, as I told you earlier, our task is to reduce the complexity of the input text you are going to give. So talking about that, in language we used to have some of the combination words which don't have or carry any important meaning on their own, which is required to build a sentence, right? For example, we have the yeah and etc. So we call it as stop words in NLTK. So stop words are words that occur frequently in a language and they do not carry much meaning on their own, such as, okay, so I think the task is to make individual words. If you split them into alphabets, character or alphabets, then I don't think it will make any sense, because if I am speaking any sentence, for example, if I show you about this sample sentence, can you see it? It is about, just read this sentence or paragraph we are having. So it's about a basketball team. Okay, so if you understand this, if we convert it to numbers, we can find the name of this is Blue Whales. It is repeating in many parts, and basketball and championship. Okay, so with words it has meanings. Okay, so we are splitting into words, but if you split it into characters, then it don't carry any meaning, so it will spoil our party here. So it cannot, we cannot perform with that. I hope you understood that. Is it clear regarding the idea behind this? Yeah. So talking about here, the stop words are words that occur frequently in a language and they do not carry much meaning on their own. So stop words are, we used to remove these stop words so that we can find some important words which carry the meaning from your input. Okay, yeah. So stop words are often removed during text pre-processing to reduce the amount of noise and focus on more important words in the text. And these words are available in NLTK stop words and they can be used to remove in our data sets. So we have the stop words, a collection of these stop words from nltk.corpus. So you can use this, and how you can use this. Now what I'll suggest you to do is, if you have a paragraph, convert it into words. Once you turn them into words, what you can do is just keep it and then go with nltk.corpus import stop words, and in stop words you have to choose words from English. So I'll be storing it in the variable stop. So if I run this, you can find these are some of the common repetitive words which is called as stop words which we are having here. So what I can do is, I'm having a list of my words, I'm having a list of these words. I can just use a for loop and conditional statement, and once again it is counting. Also we are having the punctuation marks here in our sentence, right? So I think it's better to remove that too. If you wish to do that, you can call for punctuations from string. So I'm storing both of this here, and I can directly, I'll create a new list, and I'm just looping over my words, and every time I loop over the word, I'm checking whether X not present in stop and punctuation. It's a AND operator, which means it will check both here and here. If both are true, then only it will proceed into the conditional statement. So I'm checking for individual words whether it's not present in the stop words and punctuation. If it's a stop word or a punctuation mark, then it won't be adding in this new list. If it is not there, which is actual important word, then I am just appending it to my list. So now if I print this new, you can see the words which should be like away from our stop words. Okay, so you can check the length of it. So now we have 140. Previously we had around, do you guys remember, 156. Okay, some of the words has been removed, punctuation marks has been removed, and so to convert this list into a string or a sentence or a paragraph, once again you can call the string operation, call a empty string and call dot join, and you can pass a new this variable inside that will be joined like this. The list will be combined. Okay, so now we have this text. Is it clear till now regarding the stop words, how we are applying it? If it's clear, we can see about stemming and lemmatization now. Is it clear regarding stop words, tokenization, sent underscore tokenize, word underscore tokenize? Can we see an introduction about stemming? So stemming is an important process of reducing a word to its base or root form, which allows different variations of a word to be treated as the same word For example, the stem of the word running, runner and runs is run. Okay, so the stemming is not always perfect, and it can sometimes result in a word which is not even a real word. Okay, so for example, the stem of the word was is wa, which is not even a real word. If I tell you an example what is stemming, this single image can tell you what is stemming. So in the paragraph, if you are having changing, changed and change, the root word it will find is chang. You know the meaning of it. Not only this, sometimes it will proceed with change. Okay, that's the tense changes, right? So it want to find. And for example, studying, studies and study is turned into studi to find its base word, right? So you can, why we are performing this? We are trying to reduce the complexity. We are removing unnecessary words. We are trying to reduce its complexity. And I am going with from nltk.stem, import porter stemma and stemma equal to porter stemma. So now I am using another for loop. Okay, and using this for loop, I am creating a new list and adding the words which is stemmed from this. I am calling the stemmer to stem. And let us see the output and compare. I'll join this and we need to compare both of these sentences. Can you find any word which is not even a real word? Can you see it? Can you see it? Can I compare this paragraph? So we are having something like baseball. Okay, the word is not even completed. Believe, excite. Okay, entire. Can you see it? So this is what the output will be from a stemming part. Okay, and this is a little bit advantage and disadvantage too. So if you want to turn it into a proper word, then you can proceed with lemmatization. So lemmatization is the process of reducing a word to its base form, which is called as a lemma. And lemmatization is similar to stemming, but it produces a valid base form of the word that is found in a dictionary or vocabulary. So the output of lemmatization is a word's base form or lemma, which can be a real word or a root form of a word. Okay. So for example, like if you proceed with lemmatization, then the words like changing, changed, changes and change will be turned into change to find its root word. Okay. So to perform this, you can go for nltk.stem, import wordnet lemmatizer. So from nltk.stem, import wordnet lemmatizer. You can lemmatize that word. I'll use another loop here. Good evening. So if I proceed with this sentence, now I can find, I'll show you this new 3. So this should be like you can find that it will be turned into a lemmatized word, not a word which is not even a real word. Okay. So once again, to proceed with the next steps, I am just going to turn it into sentence. Okay, using nltk.send underscore tokenize. This variable I am just turning it into new underscore sentence. Yeah, so that's it. That's here. So and also you have bigrams, diagrams. So these are some of the advanced, like these are whatever we have seen till now is basic, and in next steps they used to go with bigrams and trigrams, which is nothing but when you talk a sentence, it will have meanings. Like each word will be having combination of words. One word is connected to the next word. To find some situations like that, you can use this and pass your list of your words. You can find the blue and blue whales, just so like that you can create tuples of words and turn it into numbers and proceed with that too. Or if bigrams is not enough, you can get trigrams and polygrams too. So this is a trigram. I hope you can see, if you see the result, you can understand how it works. So each of the 2 words will be in the next tuple, right, to find meaning whether they make sense or not. So these are bigrams and trigrams, and these are some of the pre-processing techniques we used to do to reduce the complexity of your paragraph or your sentence. Now we are dealing with a paragraph. But what if I tell you I have a project which is called as spam mail classifier? So in each of my data I'm having a mail, right? For example, I can even show you that. So this is a data set, okay, NLP data set. So I want to loop through every row here, and this is my data. So I want to turn everything into numbers here, because I need to do some pre-processing and turn it into numbers, so that I can train my model whether it's a ham or a spam. So can you guys tell me which type of machine learning problem is this? I hope many of you guys are familiar with machine learning. Which type of machine learning it is? So we have a set of details here. So it belongs to supervised learning, and in that it's a classification, and in that it's a binary classification where the data set is text message. Yes, binary classification. Very good. Classification problem. Good. So this data, if you want to proceed, so why am I telling you an example with this paragraph? So if you understand how this paragraph works, then you can understand how this is going to be applied in each of this message. Okay. So now if you have done all the pre-processing, you have other options too. You perform a lot of pre-processing and reduce its complexity. Now it's time for you to convert this into numbers. And how to do it? You can do it with the help of something known as bag of words and TF-IDF factorizer. These two are two commonly used examples. Bag of words. So bag of words is a simple text representation technique used in NLP to convert text into numerical format that can be processed by machine learning algorithm. For example, like this, if you are having a paragraph, so you will be counting how much words is repeating, what is the count of it. Okay, based on it you will be assigning some importance. But you can see now we are getting it as 6 times, so it may be considered as important in many places, so that should not be happening. I'll tell you, we have another type of it too. But talking about bag of words, so this is how it will be applied. For example, you need to pass it as a list of sentences. So these sentences it will be applying and trying to find how much it is getting the words. Okay, I hope this image will give you some clarity about how it turns a paragraph or sentence into numbers. It will count and give numbers to it. Okay, so it has some flaws too. So from sklearn.feature_extraction, we will be using sklearn here for this dot text. We will be using something known as count vectorizer to perform this bag of words task. So I'll import sklearn feature extraction, count vectorizer, and this I'm going to fit and transform to my sentence, and finally I'll turn them into an array for us to visualize it using 2array. So this is what it has been converted from my sentence which I had. Okay, so the words which are repeating, the important words, blue whales are given 1, so in many places we found 1. So like that it will try to find from the sentence, and if you want, you can proceed this matrix with your label and proceed for the next step of machine learning. But once again, this may carry or lose some of the important informations, so that's why we have another one of the most prominent or important one, which is called as TF-IDF vectorizer, also called as term frequency, inverse document frequency. It is a technique used in NLP to reflect the importance of a term in a document. And the term frequency is a measure of how frequently a term appears in a document, and inverse document frequency is a measure of how rare or common a term across the entire paragraph or the corpus or the text you are having. So if you take these two and combine it in a formula where the TF-IDF weight of a term is calculated as the product of its term frequency and inverse document frequency, two different calculations. Finally you are multiplying it, taking product of it, so that will be your output, and that value will be used instead of your bag of words. So this is what the formula for it, inverse document frequency, and if you proceed with that, you will be getting a float values in lot of places, not only like 0 or 1. Based on that you can find the importance of it, Not only you, your algorithm can also find the importance for it. Okay, you can proceed with from sklearn.feature underscore extraction dot text, import tf idf vectorizer, and you can give the same sentence and see your result too. And I hope it will find some important meaning, which are important terms, by giving some float values to it, okay, based on term frequency and inverse document frequency. With this you can proceed with machine learning algorithm, or you can proceed with neural network. Neural network will have a most prominent application, not only our algorithm, because like for example a spam classifier or a fake news classifier can go with algorithm, machine learning algorithm. But if you want to build like a summary classifier or something like a chat GPT which uses a transformer kind of things, then in such places you may need complex neural networks. Can you guys tell me what is the full form of GPT from chat GPT? GPT. What is the full form of it? And talking about this question, I need some answers. What is GPT full form? And talking about neural networks, which neural network can you apply? There are a lot of types of neural networks available. Which neural network are commonly applied for your NLP based task? Do you have any idea for it? I'll run this project too. I'm not, we'll be using the same tasks like NLTK to use stop words, English, lemmatization, and using regex to find the words alone. Okay, you can do that, converting everything into small letters, and then going with tf idf vectorizer, choosing the maximum features, turning it into numbers, training it, and then testing it using logistic regression, getting the accuracy score, support vector machine, and then finally doing some test. I'll go with, wait a minute, I'm getting some internet issues. Yes, generative pre-trained transformer, CNN. CNN is for, yeah, you can use CNN 1D for text. One more an important tool is there, a neural network which is LSTM. Have guys heard about it? RNN type, recurrent neural network, LSTM, long short term memory. Yes, RNN. CNN 2D, convolution 2D is for image, okay. So I'll run all. So we are training a model with support vector classifier or logistic regression. Based on your accuracy, you can decide to proceed with which algorithm you want. You can go with neural network too. So for example, like Twitter sentiment analysis, we will be having lot of tweets and a sentiment inside of it. In such places we used to go with, for example, like neural networks, which is LSTM. You can get combination of CNN and LSTM to make it work somewhat much better compared with all these, right? LSTM. So what's the advantage of LSTM? Have you heard about it? LSTM, long short term memory. So it will be carrying some information from the previous text. In the meantime, if the information is not important, it will be losing it, so that the complexity will be reduced and it can find some informations. And guys, I have posted one link of LinkedIn community where a lot of students are enrolled in this community. They will be constantly posting some assignments there. So if you want, you can join that community. It is based on AI, so you can get some meaningful insights from it. Students based community where a lot of information will be available. Many students will be posting their projects outputs there. You can also join. So if you want, if you have done some assignments or projects, you can post it there too. I have posted it in the chat box. If you want, please join that. Okay, so talking about this result, yeah, it has run. So I am giving some spam input here. I am predicting it, converting it into array, and then giving it to my, yeah, I am transforming it and then giving it to my algorithm to predict it. So it is predicting it as a spam mail, free entry to win ticket, something like that, based on the training part. We have class. I'll just give this mail. It's a ham mail. It is not a spam mail or something like I need leave for 2 days. It's a ham mail. So these are all ham mails which are normal mails, right? So if it's a spam mail, based on the data it has learned, it should predict. It's one of the common application of NLP. Clear? Any doubts? I think it's time. We have somewhat around 5 to 7 minutes. We can use it for clarifying some doubts. So talking about neural networks, LSTM is good. And then apart from that, when you talk about ChatGPT kind of things, it's some more advanced generative algorithms like transformer algorithms are used, which are much more complex. So if you learn all these basics, you can proceed with that too. And there are a lot of cloud providers also providing a lot of AI NLP services. If you have some account of AWS or Azure, I'll suggest you to go and look into it. So there are a lot of huge applications which are currently in live. You can use that too for free in free tier in AWS and Azure. Do you guys have any kind of account with that? If you have, please check it down. Fine. Finally, do you guys have any doubt? PyTorch will be fine. Both the combinations I'll suggest. Usually if you go with neural networks, you will be going with Keras or TensorFlow, right? PyTorch with NLTK will be fine. See, NLTK is for pre-processing and PyTorch is for creation of neural network complex algorithms, right? So they have their individual role. Is it clear? Any other doubts from your side? How was the session on NLTK or NLP? I tried to provide the introductions and hands-on too of some examples which are commonly applied in NLP. See here, everything is some sort of data. It can be a image processing, image based data, okay, musical data, text data, number data, everything finally will be encrypting or doing something which will be turning into numbers, because your algorithm or neural network can work only with numbers. You cannot give text inside of it, okay. So usually we will do that. For example, if you have idea about data science or machine learning project, you are having, for example, imagine a Titanic data set. If you have seen about that data set, we will be having a gender which is male and female. So they would have written male and female. So in that place, what we'll do something known as encoding, right? So for male we'll give 0 or 1, and the opposite will go for female and give 1 to represent it in number format, so that the algorithm can understand it's a two set of class, and it will work on it by keeping it in that way. The task of our processing is to reduce the complexity of your text. So if I am trying to tell you information through my speech, so okay, I'll be implementing a lot of other such words too. So for the combination, right? So to reduce those words and take the important words, we'll proceed with that. Any other doubts? So that's it. Thank you. Thanks for attending this session. So please provide the attendance. Link is there. And if you want, please check our community. You can join that too. So there will be a lot of assignments posted by a lot of internship users. So you can check that too. Lemmatization. Lemmatization is the turning your words to its base form called lemma. This is what lemmatization